So with the card sort, I've got all these separated into two different piles. These have to match with one of these over here. So I'm just going to use this first one here, and I'm going to simplify this one and see if I can figure out which one of these over here is equivalent to this one over here. So if you remember, I squared is the same thing as -1. So basically we're taking -1 times everything in here. So -1, I'm just going to replace this with -1. -1 times 3 is -3, and -1 times I is -I. So I'm just going to look and see which of these over here would be equivalent to -3 minus I. So with the multiplication, I'm just going to check my i's. So I'm going to do the inside 2 and the outside 2. So 4i times 2 is 8i. And 2 times -4i is -8i. So this would be 0i, or just 0. So this part right here is not going to match up with this right here. So I can eliminate this one. Same thing over here. I'm just going to start by adding the real parts. So 3 minus 10 is -7. That doesn't match this right here. So I can eliminate this card. I have 1 plus a -4 is a -3, and I have, so this part matches up here, so now I just need to make sure that the imaginary parts match up. So this is -4i plus 3i, which would be -I. So I'm going to match these two together, and I can tell that they're sorted correctly because it says that the two cards that I have sorted are sorted correctly. So I'll pull over this next one here, and we can see -4i times 5i. So I times I, that's I squared, which is the same thing as -1. So basically what we're doing is we can change that sign there. So 4 times 5 is 20. So this is going to end up being equal to 20. So we already know that this one's not going to work because we found out that this was -7. When we multiplied the i's together, that didn't work. So let's see what that would be, a 0i. So that could be a possible solution. So let's see what happens for the real portion. So if we take 2 times 2, we get 4. And 4i times -4i is -16 I squared. And remember, the I squared changes the sign. So this is 4 plus 16, which is 20. So we can put these two cards together. And again, we can see that we've got them sorted correctly because it now tells us that we have 4 cards sorted correctly. All right, so we've got these two that need to be matched up with these two. So with these brown ones here, I'm just going to subtract each one of these. So starting with this first one here, we have 3 minus 10 is -7, and 5i minus 4i is positive I. So this one is -7 plus I. And over here we have -6. This minus here gets distributed to both of these inside here. So this is really like -6 plus 21. So 21 minus 6 is 15. And 12i plus 8i is positive 20i. So let's just come over here and see if we can figure out which ones of these two are going to match up with each one of these. So for this one, again, we're just distributing. So 5i times 4 is 20i, which is starting to match this one right here. But let's do the second part just to make sure. Then we have 5i times -3i, which is -15, and this would be I squared. But remember, that I squared changes this sign to its opposite. So 20i plus 15 would go with 15 plus 20i. Addition is commutative, so you can switch around the order and it still means the same thing. So we're going to put these two cards together, which should mean that these last two cards would go together as well. So remember, this was -7 plus I. And this one we have distributive property. So if you wanted to do the area model for this one, this would be -1. And then you've got -2i plus 3i, which is plus I. And then you have 2i times 3i, which is positive 6i squared, but that changes this to a negative. So you have -1 plus -6 is -7 plus I. And so we know that these two expressions are equivalent. And now we have all of our cards sorted correctly.